Hello everybody and welcome. My name is Matt Dickinson. I am the course lead for computer aided engineering and also the module lead for engineering simulation. I do a little bit of advanced CAD and I also do this and also run some projects. Some of you know me, some of you don't. These series of webinars, what I'm going to try and do is address some of the issues that students have had in the past. So for example, a lot of you, if you are homegrown UClan, will recognize this software. You'll be sick of this software by now, and but the truth of it is you've not really expanded on this software. You've not seen the true potential of what this software can do. This is phenomenal. For those of you who've never met it, this is MatLab, of course. Excuse me, just eating. This is MatLab, of course. This short video is just to introduce those who have never seen this before. We're going to have a little bit of a navigation around the software. I'm going to introduce you to particular points and a little bits of functions of what this thing can do. These are quick off-the-cuff functions. As we start to navigate a little bit further into this, you'll start to really open up the ability of this software. It's a phenomenal bit of kit. My PhD was purely written in this, and I could not praise this software anymore, even though you look at this and it's dry. It is boring. It's like opening up Excel and then somebody saying, right, how good is that? You think, yeah, it's about as good as pulling teeth. So let's have a little bit of a navigation through. So starting from the command window. Normally when you open this software up, you'll notice that the command window will be flashing. Now you'll notice here, this particular area here, this is just an icon just to confirm that everything is up and running. With the command window, you can execute code, you can execute SImulink models, you can execute quick calculations. So for example, if I say A is equal to 40 and B is equal to some random number, and then I say, oh yeah, but I need to know what the division of the two is, so I say C is equal to B over A. This will quickly give me a calculated response. It's quite good because it means if you're doing any type of analysis on a component or on a system as it's in dynamic motion, sometimes you just want to get that answer. You don't want to mess around clicking run and waiting for a simulation to execute. You can quickly get a straight answer from this, and the command window will allow you to do that. Those of you who study motorsports, you'll do a little bit more on the command window with Graham. Graham will take you a little bit further into that. But anyway, moving on to the left. The detail window. Detail window is exactly the same as the preview window that's attached to Windows. So as you know, if you have some icons on the screen, you can left click on the image and it will show you an example of how it runs, or what's written in it, if you will, or whatever it is that detail is. Now this is the same process. If I click through, let's see if there's anything here of any use. Trouble is, because these are basic execution files, there's nothing detailed. If you download a file of a Simulink library, for example, sometimes you can come up with the most inventive names and you think, yeah, never going to forget that. You click back and go, what the hell is that? Often having this detail file lets you have a quick look to see what the hell it was, and you kind of go, oh yes, I remember. Anyway, so that's all that really is. Up above is the current folder. Current folder is vital in what you're doing. I would always recommend anybody who is doing analysis, any sort of simulation, any type of things like that, to always start a folder, call it project whatever, or you know, if it's a quarter car project, quarter car, whatever, but always navigate to that point so everything is stored within it. Because if I start to save here, this folder location is the first place that it will go to. You move that folder and it allows you to make sure everything's stored to that. I mean, I know it's not too much of brain boxing, but it's these little details that will make your life a million times easier. The other thing to keep in mind is, if you look on the folders, you'll notice that each folder is grayed out. This is because those who have used Autodesk Inventor, SolidWorks, ANSYS, COMSOL will all know that what these systems do is they don't load everything in. They try to keep everything as efficient as possible, because nowadays the simulation softwares, the CAD softwares are getting so big that if you try to load everything in one go, it would take forever to load. And once it run fine, but it just doesn't sell speed, doesn't sell efficiency. So what they actually do is they turn a lot of the functions off. So one thing about this is when we move into Sim Multibody, we'll be using CAD models. We will use models that have been pre-generated. We will build the model, we will simulate the model, and we'll look at the reactions from each system. Now the issue is, if you're going to import something like a STL file, or let's think a step file, an IGES file, an STL file, any of these pre-written translation files, you need to be able to tell the system where these files are stored, or else what it will do is it will kind of come out and go, no, not doing that, not happening. And it can be frustrating. I mean, we're going to visit this quite in depth. We're going to keep looking at this because I want to get it through. I want everybody to be clear about that is what it does. If I wanted to, for example, if I wanted to add Win32 to the file format, I can right click, and you can see there I can add my folders and folders and subfolders. We're not going to do that yet, but as we go through, we're going to look at that and keep re-examining that. Right, now above, as normal, you've got to up level 1. So this is C file, program files, MATLAB, R2018B, and in the bin file. Now if I jump up one, you'll notice I've jumped out of the bin. So it is just a jump up file command. To the right of that is my personal favourite. It's what I prefer to use. So I'm going to use browse for folder. With this, I normally browse to, let's browse to some of the lecture notes that I've generated for this module, and then I'm going to click onto here. Now you'll notice I've just clicked onto the folder, and I can click on to select folder. So if I select the folder from that, what it'll do is it will open the folder. It is not particular to open up a file itself. It's just looking for an initial location. Okay? Right, so let's move on a little bit. Coming along from the top. I mean, this is not too much of brain boxing. New script. We are going to do a bit of scripting. We're going to look at perhaps a first order, a second order system. We're going to encode using Euler's methodologies, or Euler, or Euler, or whatever, or however you like to translate it. I've heard it said so many different ways. It's phenomenal. But we are going to use scripting. To the right of here, you've got live scripting, and I may do a bit of a spin-off with this because there's a lot of detail in here that I'd like to add, but we'll just move on slightly. So to the right of there, we have new. If we come down, scripting, live, yeah, we've just visited these. But we are going to be visiting the use of figures and also Simulink models. To the right of, yeah, we've got to open. I'm gonna take it into consideration by now that you've got used to what open means, so let's just move on. Import data. Now this is a really useful tool. Let's say, for argument's sake, you've been you've got a black box from a drone's flight, looking at the flight path and so forth, or you've pulled some data acquisition from the Ricardo dyno in Wharf. Typically, these processors will either put out two different file types: put an XLSX file, which is your Excel file, or it will put a .text file where it will just put out different data sets. Import data for this is exactly that. You can transpose, you can move, you can put column to row or row to column, whichever is the best. You can pre-process that data, and it's quite good if you're in a position where you need to import. Okay, so moving on. Save workspace. Now, the reason I've not cleared my work area yet, if you look at the workspace here, interestingly, I put in the data earlier. Now, with MATLAB, what it actually does is it kind of looks and says, yep, he's written that down. He might want to use it. So it actually generates these as variables. These are useful variables. Well, I mean, that's just an off-the-cuff thing, but it depends what's being outputted. It tries to store data sets. These are quite useful. These are like references as to the last simulation run that you did. Another great useful thing that I've just realised I've missed is if I click onto the command window, if I scroll up, now if I click upwards on the arrow key, I can actually go back to days and days ago to see what it was that I was typing. Often, if you find a command, which is very, very common with MATLAB, if you find a command that does a really useful thing and you think, I have no idea what I've just written, I cannot remember for love nor money, what you can do is you can scroll back through, try and remind yourself what it was that you did. This is a really useful thing, really, really useful thing. Right, so let's say I've outputted lots and lots of data here, and it says, I don't know, with 60, 70 variables with hundreds of different data types in the values. If I click on save workspace, you'll notice there it saved it as a MATLAB file. All this is actually doing now is it's took a snapshot of everything from in here and said, right, I'll take a snapshot, put it into a single file. And you see here where I have open variables. It's not from open variables, that's me talking crap. If I go to open, I can then reopen the variables that I've saved. And another thing here now, I know what you'd be thinking at this, but if you go down, we have clear workspace. Now, I mean, a lot of people go, yeah, that's difficult to understand. Obviously, it does a basic thing. It just basically clears the variables. So if I do that, you notice it gone. This, as silly as it is for this is actually very useful. Say you're running a simulation, it runs through it, and every time you run it, for some reason, for love nor money, it just keeps dying. No idea why. What can actually happen is, if we run a script, if we run MATLAB, anything like that, what it will be doing is storing these variables here. So if it's vital for you to start a simulation with a predefined variable, what it actually does is it looks and says, oh no, it's alright, you've got it in the workspace. And then it will lead to your simulation ballsing up. Trust me, I've done it many years before, and many moments of screaming and shouting and lots of harsh words. Anyway, so as a tool, really useful. If you get to the end of a sim, I'd always recommend just clear your workspace, unless in particular you do need to save some of it. If you need to save it, save the workspace, save it out there, then clear the workspace, run it again, and keep doing that. It's it can save you a lot of time and a lot of frustrated and screaming and shouting. Then obviously from here you have clear commands. To be fair, once we get into this, you'll end up with thousands and thousands of lines telling you different outputs that are coming. So often clearing the commands can really help tidy everything back up and make it all a little bit more manageable. Again, just to point out, if I scroll up, it still remembered the variables that I was using, which is happy days. So that's one important thing. Right, so we move on to the next bit. Now, SImulink. One thing to keep in mind, SImulink is a bolt-on to MATLAB. It's become so big, it's practically its own software. But the important thing to remember about this is SImulink cannot run without MATLAB. MATLAB is, see it as MATLAB is the main system, the main engine of the car, if you will. And then SImulink is, you know, the extension, the bolt-ons, the push rods, the chassis and so forth. It's in essence, it's a build, it's a construct to it. But it has become so big, it's become its own entity. I'm not going to click on that just yet because I just want to finish just giving an overview of this interface in itself. Layout. Now this is really useful. Let's say you've got some total idiot that's come along and he's thought it'd be really funny to dislodge all these areas. if you're new to the system, it can be very, very off-putting, because you can come in and go, where in the hell is everything, and how do I reset it? Coming to layout and clicking default will take whatever was done and reset it back. It's really, really useful, because you can often get in there and go, oh, it's not working. You go, well, you're wrong, because you've not reset the interface. It's just because some idiot thought it'd be a great idea to pull a trick. So until you're confident, until you're comfortable with this interface, until you're comfortable with navigating around. I mean, I've used this now for about 11 years, so I know this now. I've got used to it. So I'd always recommend the default layout. So always put in the default layout. It just allows you to navigate that a little bit easier. Preferences. Preferences are preferences. I mean, you go fonts, for example. It's exactly like navigating through anything. We will be visiting preferences quite a bit, just because when we move into Simulink, we want to look at the solvers that we're using. We want to look at time variation that we're using. We want to look at variable time responses as compared to fixed time responses. Just depends exactly how we want to do it, but these are some of the things that we want to do, so that's just something to keep in mind. And set paths. Now, I was saying earlier about being able to allocate positions of things, being able to set something for MATLAB to always look at. The set path positions, it's a great thing, because you can actually say to it, use this path location, go to that path location, and always push it to do that. It's a really, really useful thing. We will look at that. So we will look at that, and we will also look at adding path locations and the difference in automatic location to setting locations. Moving on. Add-ons. Now, anybody who's accustomed with microcontrollers, this can be Arduinos through to Mbed 303 processors, anything like that. This is where you can actually get bolt-ons for Raspberry Pi and just Arduino. At the minute they are limited to it, but I will do a little bit of a extra to this. We're going to examine this a little bit. We're going to examine a little bit of how you get it to work, so you can get it to the point of where you plug your Arduino Uno in and it will instantly see it. The thing is if you wanted to move to something a little bit more powerful, something a little bit more quicker and a little bit more professional, you'd end up using something like an Mbed Nucleo board, due to their voltage demand and their ARM processor makes them far superior in many ways. And also the Raspberry Pi, you may want to use something like an Odroid. Should point out there are no bolt-ons for the Odroid on here. I've yet to find out to see if they are going to look to do that, but because at the minute obviously it's not just Raspberry Pi anymore, there's quite a lot of competition as far as these little boards go. But I will do an add-on to this. I'll do a little bit of a spin-off on this, because at the moment what I want to do is just focus on what we will be doing in classes and then expand on that. So I can't stop burping. Now, so to really have the webinar idea just allows us to expand that a little bit, and being able to expand makes life a little bit more easy. And also, if I start to bore you of some sort, you can always fast forward. Okay, moving on. So now I don't know how true this rumor is. Somebody told me that before MATLAB looked like this, because they've only looked like this now for 5-6 years, I think, maybe a little bit longer. Supposedly they got permission from Microsoft to use the bar structure similar to Excel. Now it seems like a really tall order does that statement, but supposedly that's what happened. Don't know how true that is, but as a tool, the beauty is this interface is exactly like Microsoft Excel. So imagine MATLAB is Microsoft Excel on steroids. So let's move on. Go to plots. Yeah, in itself, you see here we have plots, different types, bar charts, scatters, pie, histograms. However, if I click down, what we have here is different type of statistical analysis tools, different types of ways to plot. We got right through to control system, financial tools, DSP monitoring, image processing. For those who are interested in OpenCV, you can look into this for deep learning data sets. It's a phenomenal bit of kit, phenomenal. And this is one of the reasons why I think I'm so enthusiastic about it, because somebody once said to me that MATLAB will do anything, you've just to be smart enough to use it. The worst thing is, though, is anybody can pretty much get anything going, but this kind of really exploits the idea of how dangerous this tool can be, because it means anybody can really build a model, but unless there's some sort of good solid data sets behind it, what they've actually done is they've just put a load of crap in to get a load of crap out. So these are things just to keep in mind. Okay, so this is your plot spot. Let's go to apps. Now this is really cool. I really like this. So these are quick codes that will function together. I say quick, probably took a while to get these things together. These are tools to actually automatically execute different things. So line optimization, regression analysis. Let's have a look what else we got. Biology, computational biology. My God, I tell you, this stuff nowadays can do anything. Somebody else told me though that what you can do is, these were originally formulated from the MATLAB owners. They started to build these up, but then a lot of the users started to develop these as well. And the online source, the file exchange, the MATLAB file exchange, this is an online community. If you haven't joined it, I would recommend that you go online and you join it. It's a great place to go for stuff. And if you're unsure about executing, I don't know, let's think of a PID controller, or if you're wanting to look at somebody who's done a drone, it gives you just a bit of incentive is to figure out what's the best way to attack this. Because one thing to keep in mind, when we start to build this stuff up, it gets incredibly tricky and incredibly detailed. And tracking somebody else's performance on this can be really, really tricky. So, not to frighten you off too much, but it's just something to keep in mind. Right, so this is the MATLAB interface overview. Let's move on. You'll notice back on home, click onto SImulink. Right, when this opens up, you'll see the SImulink start page. Now on here, we are going to examine this quite a bit, but we will come back to this. One thing to keep in mind is I was told that if you bought everything on MATLAB, it works out something along the lines of £150,000 or something like that. So what you do is you buy MATLAB, you buy SImulink, then you buy toolboxes. You'll notice down here, you see these different toolboxes here. Don't ever listen to anybody if they say, oh, I'm a MATLAB genius. You think, well, it's a lot to know about. You'll never really come across anybody who knows everything inside out. There will be specific strengths to that area. So for me, personally, it's all about things that are moving and mechanical systems in SImulink. I've done it quite a bit, but when it comes to, say, audio toolboxes, things like that, I will tell you, I know nothing. So coming from the SImulink start page, let's go to a blank. You ready for this? This is amazing. And that's it. Whoa, I'm just playing, by the way. It looks a bit dull, granted. Looks a bit boring, I understand. But what it does do is, this is our workspace. This is where we will do all our execution from our major complicated models. In these webinars, what we're going to do is we're going to look at some equations. We're going to look at differentiation in a second order system. Then once we're happy with modeling equations, we're going to move on to modeling the mechanical system. Once we're happy with modeling the mechanical system, then we're going to move on to taking the equation that we modeled and the mechanical system and getting the equation to affect the mechanical system relative to time. But yeah, we're not doing that just yet. So let's have a quick look around. Top left, as you can imagine, we can do a blank model, fresh model, charts, libraries, projects. We're going to stay with the blank page. Again, I'm not going to explain what open is because, well, it's open. Here is the most interesting one. So, library browser. What it'll do now is it opens up the SImulink library browser. Whoops. Ah. Wow, I'm actually all over the shop at the minute. Right, so in the SImulink library, very useful. So, coming down from above, one thing just before we start, if you look down this list, you see the number of toolboxes that are there. Each toolbox, I'm told, is about £600-700 each. That's a lot of toolboxes. That's a big old investment. I don't want to stress it out just because the university has clearly invested a lot of money in this, which I won't lie, I'm very thankful for. It makes me being able to use this so much better. One second, expand that out. Right, so moving down, you'll notice at the bottom, on SImulink, if I expand this and go on to commonly used blocks, this is very, very useful. We have bus controllers, we have selectors, we have muse, we have demuse. This sounds like I'm speaking an entirely different language. I should point out a lot of students say demux and mux, when it's actually demu. A student put me right not too long ago, that's why I'm actually saying it. As we go down the list, these tools in themselves, constants, gains, grounds, we are going to use these time and time again to be able to structure certain things. As we go down the list, math operators, as you would imagine, we've got absolutes, we've got products, gains, we've got square roots, we've got all the different tools that we need to be able to manipulate, change and analyze, or post-analyzing the data as it comes in. It's grateful, really great bit of kit. So as you come a bit further down, we go to sources, happy days. An issue that you have, if you start to build a model, let's say you were going to look at a quarter car, you need a road building, and you kind of think, how the hell am I going to do that? You actually have to generate a signal. Now you look on the right here, we've got a signal builder. You can actually put together the type of input it will be, so you can randomize this generation, so it's kind of like it's going over a bumpy road. What we're going to do is we're going to look at different tools on this list and different signals to try and look at what it can do and what type of input they give. Okay, let's have a little bit further down. Now, one of my personal favorites down here, if we go to Simscape, multibody, you'll notice on here we have belts. Oh, this is amazing. What we can do is, if we have a pulley system, we know what the radius will be, we know what the line will be, we can actually put that in and actually look at what type of forces are generated, what types of torques are being put out there, what type of angular acceleration is being recorded, and all types of different things with that. The same thing goes with the belt properties. All it needs is upper and lower radiuses to give it to the drive, and obviously the distances in between to give it that drive. And when we get on to body elements, this is just an overview to give you an idea of where everything sits. We will be concentrating in particular on solids, but probably we may be visiting a little bit of variable mass. These masses are amazing, by the way, but yeah, we'll probably visit a couple of variable mass. Right. Let's just come back. One thing I wanted to do. So what I'm going to do is, let's say for my commonly used blocks, what I wanted to do is I wanted to use a constant, a scope. All I simply do is drag that in. Any minute now. There we go. And drag a scope in. Now, as that comes in, you can either roll your mouse and get it just about. Oh, hang on. Shit! Oh no. Or, if you don't want to be messing around, press spacebar. It's a zoom to fit. Great, useful bit of kit. Really, really good. Because if you have models where you have 50, 60, 70 connecting bodies and joints that are being defined by different forces, different equations, to have something like that makes life so much easier. Okay. Another great thing about this is, let's say I didn't even want to I didn't want to even go into my SImulink library and mess around trying to find the right one, because sometimes you can think of something, you think, I know what it's called, but I cannot remember where the hell it is. So if let's say I wanted to do a signal builder. Let's go SIG. Right. So I've typed it anywhere on the screen. If I left click, signal. A student showed me this. It's a new function. I looked and it was like, oh my god. For when I did my PhD, this was first generation, what they called sim mechanics, and we had to build everything up from scratch. As now, I can just say, I want a constant. Oh, I could do this all day. You got to forgive me. I don't get out much. So as a bit of the kit, it's incredible. Really, really useful. Really useful. One thing to keep in mind is, as we move along, we will be visiting model configuration parameters. This allows us, this is the preferences of your predefined simulation that we are in right now. We'll be visiting that because we can change things, we can update things. We will also be looking at Model Explorer, because let's say, like for me for example, I wanted to model my piston rings through variables. But the thing is I didn't want to have to put the variables in every 20 seconds. So I wanted to set a predefined variable, and then I could modify that whenever I suited. That is all done through the Model Explorer. We will visit that. We'll go into quite a bit of detail on that. Obviously run. This is useful. SImulink Data Inspector. Now, when you're running something big, if you're running a massive simulation, let's say you're, I don't know, looking at a wind turbine and its efficiency over 20 days, or so forth, to run something like that. So when I ran my KTM 550, what I'd actually done is I ran the simulation and I was looking at the running in procedure. So it needed to run for an hour, and I wanted to look at different variations that were occurring when, say, RPM was basically the load or the angle of the throttle body, just to see what type of effect it would have on compression ring dynamics. The trouble is, if I put in a variable that's out of a unit, so let's say I wanted 1 mil but accidentally put 10 mil in, because of the system will still execute. And if it runs, a lot of the time you can't visit data, you can't be sure about what's happening. Now the Simulation Data Inspector, if there's one thing in particular where you think, if I can see that, I will know if that's going on, yes or no, you can have that live updating, checking it. So if, like my simulation for example, because it was an hour of real time, it took, I think it was 10 hours on the simulation time, because this was analysing dynamics of everything and the thermal coefficient of expansion in all three planes. Obviously more influenced by just two. What this really allowed me to do though is to inspect it, just to make sure that if something was going wrong I could interrupt it, or else, yeah, lots of tears, lots of awkward moments. Okay. Further, we have time of simulation running. As you imagine, 1 second, 200 seconds. If you're running continuously, INF. I do need to warn you, do not run this if you're not ready to, because sometimes you can spam the memory and because this thing will just keep running on an infinite basis. basically by typing INF you're saying I don't really want a specific time frame, I just want you to keep running and take sample blocks. Now the sample blocks we will look at, the time samples we will look at, because MATLAB also has a very cool function in this. It allows you to be variable time steps. It can make things more efficiently, but sometimes can also trip you up. Hence why you have the ability to jump in and out of them. Right, so that is, oh, where are we? That is MATLAB in a nutshell. This short, my goodness, 35 minutes, I can't rabbit on. This short video was just to give an overview of the function itself, of the tool itself. Because often at first it can be a little bit intimidating just navigating around it. I do promise you that the software itself is not as dull as it looks. Next, what I think we're going to start looking at is basic scripting. We're going to do a little bit of first order systems, and then we'll move on to bigger and better things. Again, I hope I've not bored anybody, and I hope you enjoyed the short introduction. See you soon.